This is a lesson about pi. Pi is perhaps the most famous number in mathematics. Pi is approximately 3.14159265 and so on. Pi is irrational. Irrational in mathematics means it cannot be expressed as a fraction of integers. Another famous irrational number is the square root of 2. Finally, pi is transcendental. What it means for a number to be transcendental is that there is no polynomial equation with rational coefficients of which pi is a root. What this means is I cannot write a polynomial and be able to find a solution of pi for that polynomial. Also, pi can never be the zero of a polynomial. Another transcendental number, e. March 14th is commonly celebrated as Pi Day. Now you might wonder why March 14th. Well, pi is, as I said, 3.14159, and March is the third month, and so on the 14th day of the third month is 3.14, which is approximation for pi, and at 159, which is the next three digits in the sequence, that's commonly the time that Pi Day is officially celebrated, and often people will eat pies or do something special at that time. So where do you find pi? It turns out pi is exactly equal to the circumference of any circle divided by the circle's diameter. Now, this leads to the obvious consequence that circumference is equal to pi times a circle's diameter, where the circumference is just the distance around the circle and diameter is just the distance across the circle through the center of the circle. So any circle's circumference divided by its diameter is equal to this number pi. It kind of makes sense that all circles have the same circumference to diameter ratio because all circles are similar to each other. Also, pi is used in the area of a circle, where area of a circle, represented by the green here, is equal to pi times the radius of the circle squared, where radius is just half of the diameter, or just the distance from a point on the edge of a circle to the center of the circle. So it seems that pi only shows up when working with circles, but it turns out it also shows up in probability when talking about Buffon's needle. If you take a needle and you take lined paper, whereas the distance between the lines is the same length as a needle, and you drop needles carelessly onto the piece of paper, it turns out that the probability that a needle crosses any of the lines is 2 over pi. Seems kind of odd that pi would show up in this sort of circumstance when there are no circles, but in fact, it does. So how do you compute pi? How do they get pi out to hundreds, millions, even trillions of digits? Well, it turns out there are several algorithms for doing this. One, not a very efficient method, is the sequence 4 over 1 minus 4 over 3 plus 4 over 5 minus 4 over 7 plus 4 over 9. Of course, this is an infinite sequence, but as the terms go on and on, the approximation to pi gets closer and closer to the actual value. Another way to calculate pi is by using this infinite sequence, where 3 plus pi is equal to 6 plus 1 squared over 6 plus 3 squared over 6 plus 5 squared over 6 plus 7 squared over, and so on. And a very similar sequence is that 4 over pi is equal to 1 plus 1 squared over 3 plus 2 squared over 5 plus 3 squared over 7 plus 4 squared over, and you can see how the sequence continues. The 1, 2, 3, 4 goes on in succession, and then you have 1, 3, 5, 7, and so on. Continuing, we know that 4 over pi is equal to the arctan, or the inverse tangent, of 1/2 plus the arctan of 1/3. There are actually many of these things that you can come up with that equal some multiple of pi. Or the arctan of 1 times 4 is equal to pi. And now these heavy hitters are the ones that are actually used to calculate pi in most cases. Pi over 2 is equal to the summation from n equals 0 to infinity of n factorial over 2n plus 1 factorial factorial, which equals 1 plus 1 over 3 plus 1 times 2 over 3 times 5 plus 1 times 2 times 3 over 3 times 5 times 7, and you can see how this sequence continues. And finally, pi over 2 is equal to 2 times 2 times 4 times 4 times 6 times 6 times 8 times 8, and so on, over 3 times 3 times 5 times 5 times 7 times 7 times 9 times 9, and so on. Rather interesting that there are all these sequences that all equal to pi, or to some multiple of pi. Remembering or memorizing pi, there are people who can memorize pi to many digits. Some people use mnemonics or rhymes or poems to remember digits of pi. Here's one such mnemonic. Can I find a trick recalling pi easily? Now you might wonder how this has to do with remembering the digits of pi, but if you look at the number of letters in each word, the first word has 3 letters, 1, 4, 1, 5, 9, 2, 5. So you see how, this last one was 6. 3.1415926. So that is the first few digits of pi. Here's another one. How I want to drink, alcoholic in nature, after the heavy lectures involving quantum mechanics. This one was actually created by Isaac Asimov. And this one has pi to several more digits. 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, so on. How I wish I could calculate pi faster. Again, another way to remember the first few digits of pi. And certainly this has not been done using one of these mnemonics, I am sure, but pi has been recited from memory correctly to more than 67,000 digits. Here are a couple of songs that are sometimes sung on Pi Day. This first one, O Number Pi, is sung to the tune of O Christmas Tree. And the second one is Pi Day Song, which is sort of like Jingle Bells. Pi Day songs all day long, oh what fun it is to sing a jolly Pi Day song in a fun math class like this. These were actually taken from this website down here, if you'd like to check those out and find more ideas for pi. Alright, this next slide talks about, even though pi has been calculated to 1 trillion digits, and some people memorize tens of thousands of digits of pi, it is in fact useless to know or to even calculate that many digits. Suppose we draw a sphere. This sphere has Earth as its center, and the star Sirius, which is 8.8 light years away, as an edge on the sphere. So the radius is 8.8 light years, or about 52 trillion miles. So we're constructing a giant sphere. We're going to take this sphere and pack it so full of little microbes, which are just minuscule molecules, and pack the entire sphere full of these. Now we're going to take them and space each of them out the same distance apart from each other that Earth and Sirius are. So each one of these tiny little spaces is 52 trillion miles, and there are millions and trillions of these little microbes along in a row. We're going to suppose that this line of microbes, which spans longer than we have numbers for almost, is the diameter of a new circle. And we're going to create this circle around all of these microbes. Now we're going to calculate the circumference of the circle by taking pi to just 100 places and multiplying it by the diameter. And in fact, the calculation that we do with pi to just 100 places would not deviate from the exact circumference of the circle by more than 0.000001 millimeters. In other words, this circle is larger than anything any of us will ever use in our entire lifetimes. And realistically, there's no reason we would need pi to even 100 places for even a circle of this great magnitude. So, in fact, it is useless to calculate pi to so many digits. Finally, if you'd like to see more fun with pi, including ideas for eating pies on Pi Day, or making pie chains in which each color of construction paper would represent a different digit of pi, or many other ideas, you can search teachpi.org or many other Pi Day sites. Alright, this is all I have to say about pi. Thanks, Pi. Thanks.